Alright, hi everybody. This is the Math 20-1 Trigonometry review. This is question 35. Just a couple word problems at the end here. Two spruce trees are 100 meters apart. Okay, so here we go, 100 meters apart. You're not told anything about how tall they are, whether one is taller than the other, whatever. So at this point, but it says from the point on the ground halfway between the two trees. So here we go, halfway between, which means this has got to be 50 and this has got to be 50. The angle of elevations to the tops of the trees are 21 degrees. Okay, so 21 degrees and 39 degrees. Okay, so these are not the same size. Okay, so my diagram is off here. Determine the distance to the nearest meter between the tops of the two trees. Okay, that's that distance right there that we're looking for. Let's call that x. Now, to get that, what I got to do here is I got to figure out a little bit about the triangle formed by these lines of sight and then between them here. And the first thing that I might want to do is figure out that the angle in between those guys, okay, will be, now bear in mind that that full angle here to go from ground to ground would be a straight angle, so 180, and I'll subtract 21 and I'll subtract 39 from that and get that this is 120 degrees in there. Now, if I knew the length of that side and if I knew the length of that side right there, I could then use the cosine law to get the length of side x. And so let's do that. Let's call this y and we'll call this z. The assumption here, and it's a pretty safe assumption, okay, is that these trees are going straight up. So when you take a look at this, just look at this triangle, ignoring everything else there, and I got a bit of a shadow going there, but I'm looking for the hypotenuse and I know the side adjacent to that angle. So this is going to be the cosine ratio. The cosine of 21 degrees is going to equal 50 over y. So y will equal 50 over the cosine of 21 degrees. And so now we just go to the calculator. And we get that to the nearest tenth, because normally we'll take sides to the nearest tenth. That's going to be 53.6 meters. Okay? Now we take a look at the second triangle, okay? But it's the same thing. It's kind of a mirror image here. So I'm going to use the cosine again, and I'm going to say the cosine of 39 degrees, in this case, will equal 50 over z. And so z will equal 50 over the cosine of 39 degrees. Okay, and you really should get comfortable with the fact that you can just swap those two. When you're dealing with something like this, when it's a proportion but one side is over 1, you can simply swap the denominator at the numerator on the other side. Anyway, that's going to be divided by the cosine of 39 degrees, and we get that this is going to be 64.3 meters. Now, we are looking for the opposite side here. And so if we called this side just like capital X, okay, just to kind of help us label it, just to be consistent with what we've got here, little x on this side here, then I'll come over here and do this. Little x squared will equal little y squared plus little z squared minus 2yz cosine of x. And so x will be the square root. Now we can plug in the numbers. We know that y is 53.6 squared plus 64.3 squared minus 2 times 53.6 times 64.3 times the cosine of 120. Oh, always running right to the edge there. And now this is just calculator work. So plug this into our calculator. The square root of 53.6 squared plus 64.3 squared minus 2 times 53.6 times 64.3 times the cosine of 120, and we get that the distance between those to the nearest tenth is 122.2 meters. Now, you might be a little different than mine, my answer here, because I worked with the rounded solutions here. If you let the decimals carry on, if you use the full decimals in your solution here, you're going to be close. We'll be very, very close to each other, but it'll be a little off. Don't worry about that. That's not a problem.